Thank you, everyone. And thanks, Chris and Scott, for having me here. I know I'm not going to be talking a lot of technology. I'm going to be talking a bit more about the journey and the most important part of the story, which is how do we bring people along with us, okay? We call it an automation factory. You can call it whatever you want. Actually, it's not a factory. There's a lot more brain than machinery. But anyway, I'll talk to you about that. I'm the head of network and platform architecture at Colt, which means my team has the duty to make sure that our global network design, packet network design actually works for everyone. We can fulfill our business requirements, but we also take care about that growing layer of software which sits on top of the network, okay? And I'll talk to you a bit more about that later on. So I want to talk about, why am I here, overall context, why Colt, what are we doing about automation. I want to talk to you about our journey, where we started, which will be familiar to many of you, and where we're heading to. Our approach to software-defined networking, which is the umbrella term we use for that growing software layer on top of the infrastructure, even if it's not exactly what software-defined networking used to mean in the past. And then I want to go into a bit of how do we develop things and our people skills, which are actually the most important part of the story, okay? So I always start with the three bubbles, service fulfillment, service assurance, and data intelligence. This is our day-to-day landscape in the telecom sector, okay? So we have to be able to fulfill the services, we have to be able to assure them, and we have to do something and learn something about them so that we can get better, okay? It's actually fairly simple. The problem is these bubbles themselves, they are no longer the source of the value, okay? The source of value actually comes in the intersections across them, as we put it. And more specifically, right in the middle where everything gets together, okay? How do we make networks be intelligent for the business? How do we make them deliver value? And how do we make the business actually consume that value, okay? And that's exactly the direction of travel where we're getting to. We want to make the bubbles themselves as transactional as possible through automation and simplification, which is now a mantra we have at Colt. And we want to focus on how to leverage on those automations to deliver exactly the areas which are intersecting those bubbles, okay? So we have four main parts of the main capabilities to build our SDN strategy and to leverage for our automation strategy. First and foremost is the network infrastructure. So we have been working since 2015 to build our IQNet network, which is a multi-service platform, has a global reach, and we have some toys there in the infrastructure that we can use to deliver value. But are we using them? Are we milking them? No, we are not. Our operational guys are using a lot of them. People on the ground know about them, but the business is not benefiting of them. As simple as that, okay? And that's a very, very harsh statement. So what do we need to do? We have to open them up. We have to make them available to the business. That's where software comes in. So the things that are transactional, make them truly transactional, make them consumable. The things that are less transactional, more bespoke, more configuration, let's try to manage them through the automation itself, okay? And that's where we get into modeling the technology. How do we model the devices? How do we actually push the configurations in a traceable manner? How do we roll back? How do we introduce the frequent change? Which I can tell you there's a lot of people averse to it, and you know that. Third one is actually, well, those things don't govern themselves. They don't work autonomously. You have to have people, brains behind them, coding them, building them, driving them, nurturing them, and eventually expanding them. And also, not only that, you have to have those people actually predicating them, talking to the business about them, bringing the operational guys on board, bringing the marketing guys on board on why these things are good for our customers, why do we need to invest in these kind of things, and why they must never be a silo hidden underneath and buried on the ground, okay? And the last part of it, which is our ambition, is how do we build all of this capability, and on top of that, we allow people to play with things without breaking them, okay, in a controlled manner. And that's what we call a bit the innovation hub. It's pretty much the way we refer to it internally, but we really want to be able to open up that innovation to business. And we are proud of the amount of innovation we've done from an engineering architecture perspective in the network, but we are not yet there in having the business consume it, okay? So I had to introduce the slide on our network, but the most important part for me here in this slide is for you to understand the sort of scale of network that we are dealing with. Our core and access infrastructure is roughly, if I don't get it wrong, 3,300 devices at the moment. So we have a certain challenge on scale, and our operations guys actually suffer from it. So we are teaming up with them, trying to fix all of those things, and most importantly, trying to help them focus on what really matters and reduce their exposure to being out there fixing things by hand, okay? So what's our journey so far? We started, probably pretty much as everyone, with ad hoc automation. So, engineers building their own scripts in their own laptops. We have heard about that. You are very familiar with that. We have scripts in our infrastructure which date back to probably since we commissioned IQNet in 2015, 2016, but they are much older than that are stick to the OSS platform that we have. So there's a bit of a variety there. But what we did is, okay, first of all, we have to make people understand that there are certain things that can be automated, tasks that, we have a better way of doing things. We have to bring in a bit of a community sense. We have to make people share, and so on and so forth. So trying to think about the essence of community sharing and so on and so forth, breaking the silos in telco, okay? And we did some automations, which had a bit of value for the business, and we made them available, and then our operations guys actually could have their say on changing them and so on and so forth. And by the way, when I say we, I mean engineering, the engineering capacity at Colt, so not the operational units, okay? Then we said, okay, but this really doesn't scale. We need to go a bit bigger than that. We have to do a bit more of end-to-end process modeling for managing the infrastructure. We have to be able to integrate that with our scripting capability and so on and so forth, because otherwise there will be no means people in the business will do that. So we thought, okay, what other tools can we bring in? Do we continue and grow our existing baseline toolset, which I will talk to you about in a second? Do we bring something else? And then we started thinking about, okay, let's design this platform, okay? Let's bring some architecture principles, how we want to do this, which align the network architecture and the software architecture on top, okay? And again, this is far away still from the OSS BSS stack. This is network domain. And we did some validation of a new software stack. We introduced a bit of agile practice, which we would predicate and people will embrace. We also introduced some concepts from product management, like design, user-centered design. So actually talk to the stakeholders on the ground and try to get those requirements in a way that we can deliver value to them early on. Things that we know, but actually they are not really done on the day-to-day rush, okay? Third part of the story then, the third stage for us is, okay, we have a platform, we have this kind of SDN platform architecture, we can bring in scripts and do more complex workflows. We need to then expose this to the business, to the OSS stack. And there we got, our very first problem. Our IT colleagues already built the monolithic vertical integrated OSS stack, which did automation for the network back in 2016. So we had to have a conversation about who owns this, who's responsible for that, what do we do when things break, how do we trust you guys, network engineers, to actually do proper automations, and that sort of conversations, which are real fun, especially when customers are calling because they have problems with the services, or when we have to deliver X amount of increase in revenue, and so on and so forth, okay? But we had that conversation. We had to have that conversation because we clearly saw we cannot continue with a vertical integrated stack. So we went straight onto that and said, we know how to do APIs. APIs are not rocket science anymore. There are frameworks to do that. We know how to do automations. We have scripting, we have skills, we have practice, and we have a tool stack. So let us do it. And we managed to get through that, and I'll explain to you, how does that work from a technology stack. And then in the future, we want to do much more things, of course. We want to go into the mantra of closed loop and eventually bringing AI at some point, and those kind of marvelous things that will allow us to be truly transactional for the things that really don't matter to the business, okay? So we started with our network automation framework, not forum, back in 2021, okay? And it was based in Rundeck. Fundamentally, it was bringing together Rundeck and Git and some script hosts in our production infrastructure. And we defined a way to move things from staging to production, and everybody developed directly in staging. It was good. It's still in production today. We still use it. And we are using it now more and more as a magnet to find out where the automations have been built, those scripts lingering around, and trying to onboard people into them and then discover the amount of stuff that we have under the bonnet that we didn't know of. And many of those automations, by the way, they sit in operations. They are there. Our operations colleagues are savvy coders, okay? And they do very, very good scripts. So we need to bring that in. Otherwise, if you go to them and say, this is new architecture, you're going to have to use this from now on, it's a head-on collision. It will never work, okay? So our approach to software-defined networking. Let me tell you what are the principles that we use in building this sort of architecture and where we got to. We had been developing automations mostly for the packet domain, but never for the optical domain. And the challenge there is actually the landscape, the toolset landscape is very different. You heavily rely on the vendors to give you the right tools to the configurations and don't break things massively. But we didn't want to keep pushing into that direction. We really want to be able to incorporate the optical network as part of the automation stack, and at least the architectural principles should cover the optical domain. So we started looking at how do we share service and resource modeling for both domains. How do we have shared API management? How do we have shared automation approach? Task level, workflow level, end-to-end provisioning. How do we share federation systems? So one of the biggest problems always is that piece of data sits in that system over there. How do we get it? Well, everybody at the day has to implement something to get that piece of data. No, don't do it 10 different times. Do it once through a standardized way, and then you can share it across. And then the last one is, we have to present APIs at the end of the day. Let's not build 4 different API frameworks. Let's build one so that we can reuse it, and then everything drops down. And that gives us, the ambition is to have a clear-cut separation, a demarcation with the rest of the OSS stack, which is very important for us to be able to keep working in the trenches, to keep working in the infrastructure, and then bring the value back, okay? So our stack, fundamentally, our customers go through our BSS OSS systems or through our Colt on-demand portal, which was the first attempt to, the first and the existing attempt of allowing self-service to our customers. Oops, I think I blacked, okay, sorry, wrong button. Then we went into, those systems went into our OSS stack, and there are a number of vendors there I will not entertain for this presentation. And then we introduced this demarcation. That's where the SDN demarcation, the common API framework, sits. And that box there, to date, we have implemented with 3 main tools. One from Cisco to do abstraction, another one from Idential to do federation and workflows, and another tool, Rundeck, which we use as the core of the network automation framework that I was mentioning you earlier. And this is the framework that actually will have exclusive access to the infrastructure. Mostly exclusive. We will always allow ninjas to go and check the boxes if the situation approves it and if they are required to do that. But the standard way of operating is actually that's the layer that will interact with the infrastructure. And this is a bit more detail on how it looks like. So this picture here is actually that teal box that I was showing you earlier in the SDN. 2 main parts of the story. The blue area in the center is the platform, so federation and abstraction. And then we have satellite things like the SDN applications, which are fundamentally microservices we consume out of our federation layer. We have a way to interface with the other systems. That's the event bus. We have the magenta box on the right-hand side. And then we have the interconnections with the assurance stack, which has grown in parallel, but it's very coupled from an architecture perspective, because remember what I was telling you from the beginning, the intersections in those bubbles, that's where the integration between the assurance stack and the activation stack, it really matters for us, okay? So how do we develop our stack? How do we work with our peers and colleagues to deliver that? We had to think about a development model which was specifically for this platform, for the SDN platform. And there's a reason for that. At Colt, before that, there was no concept of a thin layer overlaying the network infrastructure. It was, remember what I said at the beginning, it was vertically integrated, okay? So there was no reason to have that. So we have to think of a model for developing that layer, documenting it, and being able to grow it in the future. And yeah, I mean, there are many reasons that we had to put together and why this was a good idea, so that, you know, we got buy-in from the business and from the management that would pay for the party. But the most important part for me specifically as a business owner for this implementation was we have to build some sort of trust with some partners that will help us deliver this. At Colt, we didn't go for, let's build a software development team and do it ourselves from day zero, because we knew that would fail from previous experience. So what we did is we started the journey of upskilling our engineers to understand what we were facing here, this new architecture, these new tools, and then work with a partner that knew the stack to develop it for us, okay? Or not for us, with us, okay? So we partner with them. Actually, development is very close. We drive the implementation, they do development, and there is constant communication between the two organizations. And most importantly, we also, and that's one of the things I want to highlight, it's about the architectural decision records. And that's a practice which is extended everywhere, but it was not commonly used at Colt before. We really have to write down every single design decision that we make, and we have to make it recorded, and it has to be available for everyone. Because otherwise, people, when you get somebody new into the party, or people themselves, they will forget about the agreements. And that's terrible when you are developing something like that that needs to manage the infrastructure, especially in a telco, okay? So the usual picks on CI/CD, but I just wanted to show you how do we do things. So we develop the user stories on stage one, on the planning. We have the peer process, you know, which is a dramatic change for the way our engineers, network engineers work. We have forced them to use the PR process to actually request changes or to push suggestions for design that will be discussed as part of our design forum. And it was a bit of a difficult thing to do at the beginning because they are not used to that. They used to do the changes directly. But they actually end up coming along because they saw the benefit of having things recorded and being able to discuss or written things. Okay. Once the code is available, we go on the build. So we have our CI pipeline, and we have all the different tools there. We mostly use Azure DevOps, so pretty much the tools that we have there for development. Then we go into the testing, and this is where our implementation in Robot actually kicks in. So we did an implementation for automated testing of all the different bits and pieces of the automations, but also for testing the infrastructure and the state of the network devices. Okay. We also have, as I was saying, we have the functional testing on the real devices, and I will talk to you about the sort of environments we have later on. And then after that, it goes into deployment. Okay. We have several stages for deployment, and it's not an automated deployment yet. But that's an area which we are having heated discussions at the moment. Okay? So our model overall, our development cycle looks like that. So we start, it's a fairly traditional cycle, by the way. So we start with development from development of the items in the backlog, which has been curated. We have some homegrown linting and security scanning of that. We push that into repos, and then we have 4 different testing environments before we go into production, okay? There are 3 of them which are really important for developers, for the automation developers, which is the ephemeral lab, things that they can spin up and test the automation themselves locally or in the lab, and then tear it down whenever they want. Then there is a staging infrastructure and a production-like infrastructure. Staging infrastructure and production-like infrastructure are the same. The difference is the scale. It's easier for us to test things in a smaller scale first and identify things that break frequently first in the staging, so before it goes in production-like, because our production-like infrastructure mimics the entire network, and it's fairly big. Remember, 3,300 devices. It's a fairly big piece of kit. So that's where the development happens, where the development actually is tested. Then we have another stage before it goes, which is for performance testing, which is still production-like, so yet another big lab, but it's mostly devoted for our IT colleagues to be comfortable that we are not, that we can fulfill their application performance requirements, okay? Reality is we are pushing a lot of changes, so probably we do an average, for example, of 100 Ethernet service creation a month, plus 60% of that probably are modifications. So it's not a big deal of transactions, but still we have to make sure that the rest of the OSS stack doesn't fall apart when we do that. Okay? So the part probably that is more interesting for me that I wanted to share, it's about the people. Okay, so I just wanted to share a picture on how we organize ourselves. You see in the bottom left, we have design and development, which is fairly self-contained, and we have different hexagons which represent the different roles we have in the team. Okay, we try to keep teams small so that they can still have a bit of a freedom, but the link to the rest of the business goes through this design and architecture layer that sits on top of them, okay? So we don't want the teams to be crazy by trying to figure out how to do the requirements that they get from the business, which is northbound. We have a layer of architects and user-centered designers, which understand the technology, that will filter that for them, okay? IT architecture and network architecture sit next to that, and we force, let's put it this way, our IT colleagues to join the party here. We cannot develop things that are independent of what they do, because otherwise they will never work, and they will not drive the requirements on their stack so that we can, as I said at the beginning, expose the value through APIs or through the integration, okay? On the right-hand side, you have a bit more of, what other stakeholders are there, especially if we're delivering for a bigger project in the organization, or especially for the flexing our capacity to develop. So our development partner sits on the bottom right corner. So this is the picture overall, what sort of roles you have, but what sort of journey did we actually force them to do? So you have for engineering and governance, you have 2 areas in the slide. Left-hand side is the traditional role that we used to have. Right-hand side in each of the columns is the new model. So if you can tell on the left-hand side, which is the engineering and network operations area, we used to have network engineers and network architects, and that's it, okay? Fairly traditional way of doing things. Now, when we started this journey, we wanted, first of all, the network engineers to be able to understand software, to understand a different way of working, and to understand automation, and enable them to do automation, whatever that means, whether it was scripting-based or system-based or whatever it is. So we introduced 3 sort of upskilling paths. One of them is, okay, you're a network engineer, but you need to understand the agile practice, okay? It's no longer about a 18-month waterfall project delivery, where you will deliver your requirements at the beginning with your network design, and you will go away and never happen to appear again. No, end of story. No, network engineers have to be there every single day. They have to be supporting the development, okay? Because it's the only way to validate whether we are configuring things correctly or not in the infrastructure. As simple as that, okay? So they need to understand the practice. They need to understand the automation principles. There's going to be a piece of software configuring and pushing the stuff that you have written down in your MOP, in your method of procedure document, into the box. So this is better, is reliable and robust. Okay? Second path was about the automation. Okay, so as a network engineer, if you've done some development and you know how to do Python and you can do scripts, you probably can think of in a bigger way. Okay, you can probably do things outside your silo, which is configuring that box or that series of boxes that you usually do in the infrastructure. And that thinking bigger is actually, okay, where does this fit in the whole picture? Okay, the automation of these boxes has implications on how do we engage with customers. It has impact on our service managers. It has an impact on potentially managing risks related to the upgrade of the infrastructure. And it has an impact at the end of the day in the dollar sign that flows into business. Okay, so we needed them to have a bit of a bigger picture within the boundaries of the network itself, but they need to understand how things fall in place, not just the piece of configuration that they have designed and they are pushing the infrastructure, okay? And the last path, which is a bit more interesting, is actually we force them to do testing, okay? And we force them to provide the requirements to automate the testing and to do the testing themselves. So actually we wanted them to test, especially network element drivers or the pieces of code that actually drive the box, so that they understand what it takes to run the software that actually changes the box, okay? So we no longer have a single network engineer role, which can do, the best case, some development. We have actually 3 paths of specialization should they want to go through that or just stay as a network engineer. Network architects, they've done the journey towards product, understanding product and product ownership, okay? Network architects, again, they normally see the big picture, they do the grand designs, and they align it with the strategy, but they also need to understand how these things are consumed. And they also need to understand why we do products in a certain way or not. And they need to understand why or how do we have to expose things to the business. And why is it important they know the segment routing, traffic engineering that sits in the network actually doesn't sit in the network all the time, that is understood by the rest of the business. Is there anything we can expose to the business? Can we implement intent-based networking based on segment routing as a result of having this software layer? And can we do it in a reasonable time frame, not with 2 years worth of development and nobody knows what's going to come at the end of the funnel? That's a very important one. And the last one probably it was a new role, the DevOps role. Now we have DevOps engineers within network engineering, which were not there before. They were all sitting in IT and they wouldn't even dare to cross that line, okay? Last but not least, especially in the governance side, we really have to work with the governance because network engineering, network architects, they will be focused on technical work, but we needed the rest of the business also to understand what they did, and we needed some sort of governance and protection for them. The project managers, they needed to understand Agile, fundamentally, and the development happens in a different way. No longer waterfall projects. We cannot deliver the sort of things we want to do with waterfall projects, long waterfall projects. We can make it fit in longer waterfall projects for the business, but we will not do it exclusively like that, okay? And from an analysis perspective, the technology analysts and specifically business analysts need to understand that the network is not there permanently quiet, doing nothing all the time. The network is there. There are changes that go into the network. There are changes that need to go to the network, not only when things break, but also when things need to be improved. And that improvement is not only driven by a customer request, a customer modification, it's also driven by we have better ways of doing things in the network, okay? And then a couple of roles come in. One of them is the concept of design lead, which is related to product ownership and product management that was not there before. So design leads are fundamentally at Colt doing that sort of tracing the stack, okay? So this is what network operations is looking at. This is the sort of things, the sort of requirements they have. This is how we translate this to user stories in our stack, and this is how it eventually becomes a backlog. They have that traceability and they have the ownership, and they assist the architects in building that sort of traceability. And last but not least, yeah, we have Scrum Masters. We need the police of the, and I probably shouldn't call them police, but we need somebody to police and veil for the best practice. It's very easy, especially in our telco environment, to go back to, okay, we can fix it. No, because we break many things, and most importantly, besides breaking things, is we don't allow the business to change and understand what we are doing, okay? So our takeaways, and this is my last slide. So first of all, impactful automation. What are the use cases that really have a meaning to the business? Find them fast and build them quickly, okay? We started with these scripts, and then we started talking about our stage one, about the end-to-end workflows and big systems and the design of the SM platform. Guess what? Nobody pays for a platform, and I'll talk about that later on. So it's difficult to pay for a platform. So people will expect that you have the platform to deliver something else, and the something else is what you really need to understand very quickly. Where is that? Second one, yeah, starting small is paramount. We also tried to do big things. We had to roll back a couple of times, and we went back to small and then grow them. But you need to allow for growth. Okay, if you fall again in this sort of silo mindset, and I do this because this is where nobody is bothering me and where things are rosy, that's great. You will be able to deliver some value on that front, but the rest of the business will not be able to consume it, unfortunately, or at least that's our case. Architecture principles, especially where software and network design architecture principles come together. It's very important, okay? That's the only way you will be able to grow in the future, and you will prevent having to scrap things and rebuild them again. Okay. And what I was mentioning before about the platform. Platform is great, but who pays for the platform? Our business, nobody wanted to pay for a platform. In our business, people wanted to pay for the use case and where the value lies, okay? So the actual automations, but they didn't want to pay for the platform. So we managed a way through that. Okay, so we had to find all of those use cases, try to persuade all the stakeholders that we could deliver a number of use cases through our architectural principles and a baseline platform. We validated the baseline platform. We persuaded IT that wouldn't break their stuff, and then we started working on that. And that's the way we managed to unlock the funding for that, for the platform itself. Okay, and last one, yeah, the business case. It's the most painful part of the story. If you, as I think you were mentioning earlier, if you don't understand how the money flows, chances are it will take you a lot of brain cycles to figure out and persuade people that this is good for them, okay? It's painful, it's difficult. Me, as a network engineer, it's been a super challenge to try and change my language to persuade executives that this is something we need to do and that it will help their money flows. And I'm not yet there, but yeah, we've done some progress with that, okay? That's it. These are probably the 4 words that summarize. I wanted to create an acronym for this, but everything that I could do is big F, which doesn't lead to any proper, so forget about it, okay? It's find out where the impact is, use principles to growth. Foundation has to be very clear and has to be shared, and at least from an engineering perspective, has to be rock solid, and everybody has to buy into it. And don't forget the business, the most important part of it. Who's going to pay for the party? How do you persuade them to pay for the party? It's difficult, it's painful. You will have to adapt your language. You will have to bite your tongue many times, but it's the only way to get the money to do it. Okay, thank you very much.
We do have a couple minutes for questions if anyone has something. We'll start back here. Come this way.
Hello, incredible presentation. You mentioned a lot of things related to your stack and a lot of, let's say, people skills and people positions and a lot of stuff related to this process that got you here so far. What is the component or role, or what is the most specific thing that impacted the business part the most, that people, the stakeholders, they saw it and like, wow, thank you so much for working on that?
Okay, that's a good question. There is no such a thing, okay? In a business like Colt, there are many stakeholders, and every time a new stakeholder walks into the room, they will come with a new concern, new challenge. Now, what's really important and what really allows us to actually make some progress in that respect is try to trace the automation that happens in the trench to the customer value. Because Colt specifically is very focused on streamlining customer experience. So if we are able to trace it to customer value, or if you are able at Colt to trace it to customer value, you will open some doors. Now, there are many ways of doing that. I can give you, for example, one use case we're working on right now, which is how do we use the performance management data related to energy consumption at the node level to report that back to the customers. Because everybody, or especially our customers, are especially concerned about optimization of energy footprint and consequently carbon footprint. So through this sort of architecture design and this sort of tools, we can actually harvest that data, make it available for them to report back to the business, which in our current stack or the former stack, it would be science fiction. Okay? So those are the sort of use cases that actually you have to find. And you'll realize probably from an implementation perspective, that use case is small, but from an impact, from a business perspective, it's massive because everybody is asking for that nowadays. Okay?
Good afternoon. I just wanted to say over here. Sorry, I'll stand up.
Oh, sorry.
Thank you for the presentation. It's helpful to see the journey of a company that has a large footprint. And I guess the big question I had, it looks like you've been working on this for 2 to 3 years for the foundation of your dev NetOps. How big is the team?
That's a good one. So our internal team is roughly 8 people, but we leverage on the partnership with our development partner and our vendors. So overall, probably we're talking about 20, 25 people overall, max, okay? Full-time people allocated to do this, it's probably around 12, 13. Okay. Welcome.
Hello. Thank you for your presentation. It was very... It's on? Can you? Yeah. Okay. So, yeah, I know, well, mostly everyone here, or 90% here probably are network engineers. Maybe a little bit, yeah, less, 10% or whatever, are automation engineers. I believe we are, one of the questions is how do we adopt network automation? And basically, since everything started here, I've seen you guys are trying to upskill network engineers into automation. I've seen in your team also, we got network engineers and we want you guys to be into DevOps. I want you guys to be into Python. I believe it's also something important to bear in mind, like in your team, it can be also software or automation engineers that are upskilled into networking. I think it's very, very important. And I haven't seen any presentation yet saying that. It's my network team, my junior guys are learning how to do this. Why it's not the other way around? Why don't you have software engineers or automation engineers upskill into networking? I think that will fix a lot of things and it will help with the network automation embracement.
Okay, that's an excellent question. Or maybe rather a statement. I'll tell you why I'm explaining this. As you correctly say, there are probably 2 main journeys. Network automation towards network engineers towards software engineers towards network. The biggest challenge we had, 2 big main challenges. One of them, Colt, is a network engineering organization. 99% of our guys are network engineers. Onboarding software engineers to do something that the network engineers are actually better placed for doing would be kind of very disruptive, okay? We wanted to work on what are the upskilling paths so that we have ways for the people to evolve, rather than bringing a software engineering team from outside that would have to learn from the network engineers that are doing the job, how to do things, and then they will tell them how they have to do the job. that would be a crash, okay? It is, but culturally, it's difficult. I understand the logic, I understand the principles. Culturally, at least for Colt, it was difficult. Second story is we talking to people and talking to our people on the ground, we also realized that for a network engineer to start an upskilling, a learning process that will let them know more about programming, DevOps, and so on and so forth, was perceived as an upskilling path. For a software engineer to understand how a box works was perceived as a downskilling path. It was distracting them from coding. And again, that's a cultural issue. That has nothing to do with whether it makes sense or not, okay? The problem is you see network engineers down here, which kind of skill, software engineers down here, which think they are forced to downskill. That doesn't work. Nobody will be happy about doing that. And again, I want to caveat that to our experience and where we started, trying to figure out what are the paths to success in terms of managing people. But you're perfectly right. Actually, I think that the software engineer which understands how to do good network engineering is a unicorn because of the perception, okay? And they are out there, but it's difficult to scale a program like this one that we have just by trying to hunt unicorns, okay? And again, this is my experience with trying to do this at Colt and our experience so far. But I agree with you, it's perfectly fine to go one way or the other. Culturally, we struggle with that.
Yeah. Hi. Yeah, thank you for the session, and particularly the way you just answered the last question, which was one of the points I tried to raise yesterday about where do we draw a line between a software engineer and a network engineer, who has to go up and who has to come down. Thank you for putting more clarity on that. And to my question, I would like to tap from your experience in Colt, because I know for a fact that you have a large estate of optical network, and in your presentation you try to make a comparison between automating packet network and optical network. And from my experience, I realized that in many networks, the optical part is like an island, whereby the adoption of automation is a bit slower because you have to depend on OEMs to get the APIs done and all of that. And also in my experience, I've run into a bit of issues trying to do some bits of automation on optical part, and it just never gets done. So in your experience, what is the maturity level of your optical network in terms of adopting automation? Are you still having to depend on vendors to do this, or are you able to leverage on open source softwares like Ansible to automate a lot of things as much as you like? Thank you.
Thanks for the question. So we still leverage a lot on the automation capabilities our optical vendors give us. That's the basis. We use whatever they provide with their NMSs and their software stacks, because that's the only way to get it fast. Actually, we have been following the disaggregation, optical disaggregation groups in standardization forums, and it's a painful path, okay? We are not yet there. So we work with our vendors and we leverage on their capabilities so far. What we have done with the optical domain specifically is we're trying to overlay that federation on top. Let's start with federating the two domains. Because if we design, for example, spinning up an assurance task to make sure that we can monitor an IP service on the fly through our SDN stack, there's no reason why we cannot do it for optical, okay? And then we preserve one of the principles, which is automation by design across the infrastructure. And we can then log some traces on what is the idea of the circuit that has been provisioned optical, what is the idea of the circuit in IP. We can store that somewhere, and then we can do something in the background with that. But that's, for the time being, it's an overlay. Okay, we are overlaying over the optical, whereas in the packet domain, it just goes down to the box. Okay.
All right. Thanks, everyone. We're going to break for lunch now.
Thank you.
Great job.
Cheers.